Okay, what I want to do now is to run this Tenma scope through some vertical calibration checks. And what I'm doing is I have a digital voltmeter connected to an adjustable 10-turn pot, connected to a power supply that'll give me up to 25 volts. And we're going to put a DC voltage in on each of the ranges into the scope, and we're going to see what kind of response we get vertically to those calibrated voltages. We're going to use this meter to tell us what the voltage is. So let's give it a go. We'll start with 20 volts. We right now are within 0.02 of a volt of being 20. We can 20 volts. We are right now we are grounded out and right on the zero line, and we're going to put this. We're on the 20 volt scale. Let's go ahead and switch her on. All right, we are seeing exactly one division of rise. So 20 volts per division, one division of rise. Let's go ahead and switch to the 10 volt scale. Double check our zero. Okay, zero is right. And we have exactly a 2 division rise. And we are still set for 19.99. We're drifting just 1/100th of a volt or so. Okay. If I go to 5 volts per division, double check our ground. 5 volts per division, and we are up right now 4 divisions. Alright, we've now calibrated ourselves to 10 volts. And we're going to check our ground. The ground looks good. And we are on the 5 volt per division scale still, so we're reading 2 divisions, 10 volts. Let's go to 2 volts per division. Check our ground. 2 volts per division, we get 1, 2, 3, 4, 5 divisions. 5 divisions, 2 volts per division, 10 volts. And we are still within 1/100th of a volt, we are 10 volts. Okay. We're going to reduce our voltage again so we can go to the 1 volt per division scale. We have a maximum of 8 divisions, so we can go to 8 volts. So let's adjust ourselves accordingly. Okay, we have now adjusted ourselves to 7 volts within 1/100th of a volt. Let's see if we can tweak that down a little. There. And we have our ground adjusted. We're going to put ourselves on, and we see that we have risen 1, 2, 3, 4, 5, 6, 7 divisions on this scale. For 7 volts, we're 1 volt per division. That's good. Okay, and let's cut that in half. Let's go to well, we got to go to 3 volts. 3 volts. And we are now exactly 1, 2, 3 divisions up, which is what we expected. Ground. 3, okay. So if we go to 0.5 volts per division, double check the ground here. Looks pretty good. Just touch it up a hair here. And we see we are now 1, 2, 3, 4, 5, 6 divisions up for 3 volts on 0.5 volts per division. So we're good so far. Let's go to 0.2 volts per division, and in order to do that, we got to cut this voltage down again. Okay, we've now adjusted to 1.2 volts. We are on the 0.2 volt per division scale. We're grounded right now and zeroed, and we pop the thing on, and we see that we have risen 1, 2, 3, 4, 5, 6 divisions. That would be times 0.2 would be 1.2 volts, so we've hit it right on the nose. Let's go ahead and take ourselves to 0.1 volts per division, and we'll go to 7 divisions, so we want 7/10 of a volt this time. Alright, we are at 7/10 of a volt, and then 1,000th of a volt there. We are on the 0.1 volt per division scale. We're grounded. We're checking our zero, which looks good. Pop it on, and we see now we have 1, 2, 3, 4, 5, 6, 7 of the grids up. So we're 7 divisions up. That's 0.7 volts. Let's reduce ourselves to half of the voltage, and we'll go up another scale. So we'll go to 50 millivolts per division. So let's take this down to 350. Yeah, I'd say we're there. It'll be difficult to get any more of that out. 350 millivolts, and we go to the 50 millivolt scale. We check our zero, looks good, and we see that we are 1, 2, 3, 4, 5, 6, 7. 7 divisions, 50 millivolts per division. That's 350 millivolts. Okay, so let's go to 20 millivolts per division, and that means we'd want 140 to hit the 7th bar. So we adjust this to 140. All right, just about there. $140 millivolts. Go to the 20 millivolt per division scale, ground it out. Pop her back on, and we are running 1, 2, 3, 4, 5, 6, 7 divisions for 140 millivolts. Okay, we're going to want to take it down again, half of that value, so we want to go to 70 millivolts. We're getting down into some seriously low signals here. Ooh. I think we're there. It's very touchy. There we go. That's about as close as I'm going to get it, 70. And we're going to take her down another notch. We're going to check the ground, the zero. Zero looks good, and we are running 1, 2, 3, 4, 5, 6, 7. 7 times 10 millivolts per division is 70 millivolts. That's exactly what we wanted, so we've done it. And the last scale position is 5 millivolts per division. And once again, we'd have to divide this in half. Let's give it a try. Alright, 35 millivolts. And let's go ahead and take her down. Check the ground. There it is. And then we pop her on, and we get a slightly fuzzy signal, but we got 1, 2, 3, 4, 5, 6, 7 times 5 millivolts is 35 millivolts full scale, or at 7/8 of the scale. So we're good. It's channel 1. Okay, we are now set up to read in on channel 2. We are still at 35 millivolts. We're at ground, and we've checked the ground. That looks good. We're popping into on, and we see that we are 1, 2, 3, 4, 5, 6, 7 divisions up. 5 millivolts per division, 35 millivolts. We're good. We're going to raise ourselves up, and we're going to adjust our scale to be 70. 70. And let's check our 0 point. Looks pretty good, but I'll touch it up just to here. There we go. And we are 1, 2, 3, 4, 5, 6, 7 divisions. At 10 millivolts a division, 70 millivolts. If we go to 20 per division, we are running 3.5, which would be expected. Let's check our ground while we're at it. It still looks good. And let's go ahead and raise this to 140. Alright. 140, that's good enough. And let's the ground. Ground looks good. And we are running 1, 2, 3, 4, 5, 6, 7. Right on. Let's go ahead and bump up to 50 millivolts per division. We want this to read 7 divisions, so at 50 millivolts per division, we want to be at 350 millivolts. So, yeah, 350. That's pretty good. And ground. And we are 1, 2, 3, 4, 5, 6, 7 divisions up. 50 millivolts, 350. Let us go to the 0.1 volt per division scale, and we see that we're setting at 3.5 divisions already, so I know we're good, but we'll raise this up to 700 millivolts. 700 millivolts. Put ourselves at ground, just do the little check. Looks good. And back on again, and we see we're exactly 1, 2, 3, 4, 5, 6, 7. At 0.1 is 0.7 volts. I'll go to 2. 0.2 volts per division. Ground looks reasonable, and we are at 700, so it's 3.5, so 1, 2, 3.5. That does do it. But let's go ahead and raise this up now to 1.4. Alright, we are at 1.4. And 0 looks pretty good. I touched it, so alright. And we are reading 1, 2, 3, 4, 5, 6, 7. At 0.2 is 1.4 volts, 0.2 volts per division. We go to 0.5 volts per division. Check our ground. And at 0.5 volts per division, if I want 7 divisions, I should be reading 3.5 volts. 0.5 times 7, 3.5 volts. Where's my mind at? Oop. 3.5 minutes. That's close enough. Alright, and let's check the 0. I think the 0 looks good. And we are setting 1, 2, 3, 4, 5, 6, 7. 7 times 0.5 is 3.5, and we have 3.5. Let's go to 1 volt per division. We are now 3.5 divisions up. We would like to be probably 7 volts. Seven volts, that's right on there. And 0 looks good, and we are running 1, 2, 3, 4, 5, 6, 7. Alright, go to 2 volts per division, and we see that we're roughly 3.5 divisions up. I haven't even adjusted my ground, but don't really have too much. Oops. There it is. And 3.5, and if we raise this now to 14 volts, there we go, 14 volts, and 0 looks good, and we see there 1, 2, 3, 4, 5, 6, 7 again. 14 volts. Going to the 5 volt per division, check the 0, and we see we are running, well, almost 3 divisions. 14 volts on this range, you can't read it. We're going to go up to 5 volts per division times, well, I can't get more than 20 volts out of this thing, so let's take her up 4 divisions and do 20. Alright, 20 volts. And ground looks good. And we see we are 1, 2, 3, 4 divisions up exactly, which would be 4 times 5 is 20. 20 volts. If I go to 10 volts per division, we are setting at 1, 2 divisions. 20 volts per division, we are setting at 1. So we've just gone through the whole doggone set of ranges on both A and B. So, okay, what have we done? We have now proven our vertical tracking. What we put in vertically on all the ranges on both channels is what we got out on this scale. So vertically we're doing good. We check the time base next, and if the time base checks out so that we know we can measure frequency, now we know we have amplitude measurements that are correct, we have frequency measurements that are correct, we should be totally correct then. And I'll use the triangle wave so that you can see that as we are doing the time-based checks, that you'll be drawing straight lines. And if you recognize them as straight lines, then this thing is linear and it's faithfully reproducing the signal. And because you know the amplitude has been measured properly, then we're in good shape then. The scope so far has been functioning excellently, and I'm happy with it.